In this video, we are going to find the value of a trig function at an angle given a diagram of a right triangle. So this is going to be very straightforward. The main thing is using the Pythagorean theorem to find any missing sides. So we need to know what this side over here is. So according to the Pythagorean theorem, leg squared plus leg squared is going to equal to the hypotenuse squared. So let's see, this is going to be y squared. 4 squared is 16. Radical 13 squared is just 13. So squaring the radical is just going to make the radical go away. So and then these are going to be multiplied, so keep track of that. And then we have 289. So that's y squared plus 208 is equal to 289. Subtracting 208 from both sides. Whoops. So y squared is equal to 81. So taking the square root of both sides, y is equal to 9. Okay, so that tells us that this side over here is in fact 9. Okay, now cosecant is a reciprocal trig function. So let's start by asking ourselves what the regular trig function is. So cosecant is the reciprocal of the sine function. So what is the sine of theta first? Well, sine is opposite over hypotenuse. So sine would be 9 over 17. So that means that cosecant will be the reciprocal of that. So cosecant will be 17 over 9. All right, that's the answer to number 23. Now for number 24, normally we would find the hypotenuse, but we're actually not going to need the hypotenuse this time. Now the cotangent function is a reciprocal trig function. So I like to start with the regular trig function, tangent. So what's the tangent of theta? Tangent is opposite over adjacent. So tangent of theta would be 20 over 15. Let's reduce that. Both of these are divisible by 5. So this would be 4 over 3. So the cotangent is the reciprocal of this. So therefore the cotangent of theta should be 3 over 4. Okay, just the reciprocal of the tangent. All right, let's take a look at number 25. Yes, sine is opposite over hypotenuse. So we don't actually need to find the other side this time. So we can just really go straight to the answer pretty quickly. So sine of theta is going to equal opposite over hypotenuse, so that's 8 over 12. So I would just reduce that. So both of these are divisible by 4, so this would be 2 over 3. All right, that was pretty easy. Okay, this one we will need to find out what this other side is. So I'm going to call it y. So using the Pythagorean theorem, y squared plus 8 squared is equal to 10 squared. Okay, so that's going to be y squared plus 64 is equal to 100. Subtracting 64, y squared equals 36. Taking the square root, y is equal to 6. Okay, now you could have done that without doing the Pythagorean theorem, okay, if you recognize your Pythagorean triples. Alright, again, the most common Pythagorean triple is the 3, 4, 5 right triangle. And maybe you can see that that's what we have here. It's just that they are all being doubled. So this is, well, let's start with the 2 that we had. This is 4 times 2. This is 5 times 2. So this side must be 3 times 2, which is a faster way to get the 6 rather than doing the Pythagorean theorem. But either way, ultimately we find out that this is 6. So now we can go ahead and do the tangent. Tangent is opposite over adjacent, so that is 8 over 6. So I would simply reduce that. Okay, so that's going to be 4 over 3. And that's it. Okay, I think that's it for this video. On the next video, we're going to be solving these trigonometric equations. So if that sounds like something you want to learn, I'll see you on the next video.